Okay, students, this is part 2 of our Toxins lesson 19, and it's about pH, H plus concentration. Of course, that's what we get from acids, and the hydroxide, the OH minus we get from bases. So the equations that you saw in the first lesson are still there right here. And the first one is the relationship between the H plus and the OH concentration. They always multiply out to 1 times 10 to the negative 14, those two numbers. And you might remember this chart. In this chart, when we had a high concentration of H plus, we had a very low concentration of OH minus. The pH, of course, is very low because it's very acidic. There's a lot of H plus. And as we move here into the middle, neutral is where we have the same amount of each, 1 times 10 to the negative 7. Of course, again, that multiplies out to 1 times 10 to the negative 14. And if we're down around this end, where we have more base, more hydroxide, these concentrations are very high compared to the acid concentrations on this side. So when we have a lot of hydroxide, we have a base, and we have a lot of H plus, we have an acid. And there's always some of each in solution, but there's always some OH and some H plus because of the balance in water. All right, here we go. We want to solve this problem right here. What is the H plus concentration of a solution that has an OH minus concentration of 6.2 times 10 to the negative 2 molar? Is this acidic, basic, or neutral? So let's see. What's the H plus? That's what we want to know. And we're told this concentration right here. So it looks like we're going from here to here. We're trying to get the H plus from the OH. That's this equation right here. So we're going to start with that equation, and we want to find the H plus. So we've got to move this underneath over here. Right? You're going to divide that on both sides. And that gives us H plus equals 1 times 10 to the negative 14 divided by the OH concentration. And the OH concentration is right here, 6.2 times 10 to the negative 2 molar. That's the concentration of the hydroxide. And so if we do that problem, we'll have our answer. Let's see here. Okay, let's see if you remember. We're going to do, in parentheses, always put parentheses around your scientific notation, 1. And remember, we're going to do not times 10, but second EE, and that's the times 10 to the button. And then we're just going to type in negative, let's see, my negative button is right there, 14. And I'm going to close parenthesis, and then I'm going to divide by and use my parentheses again. So that's 6.2 times 10 to the, and this time negative 2, close parenthesis, enter. And 1.6 times 10 to the negative 13, 1.6 times 10 to the negative 13 is the H plus concentration. Okay, so is that acidic, basic, or neutral? Well, that's a pretty low number compared to the hydroxide. There was more hydroxide than hydrogen, so that has to be a base. And here we are where the H plus is down in the 10 to the negative 13 range. That's, of course, when the OH is up in the negative 10 to negative 2 range, and that's basic. So basic. Okay. The next problem. What's the OH concentration of a solution that has an H plus concentration of 4.5 times 10 to the negative 4 molar? So that is greater than 1 times 10 to the negative 7. So this looks like this is going to be acidic. Is this acidic, basic, or neutral? So first we're going to find the OH, and then we'll compare it to that number. It should be quite a bit less than that. So this time what we're going to do is we're going to start with this equation again, the equation that goes from OH to H plus, or in this case, H plus to OH. So we're going to take our hydrogen and move it underneath here. So we're going to divide by the H plus and divide by H plus. Those cancel. And we get OH equals 1 times 10 to the negative 14 divided by the H plus. And that H plus is 4.5 times 10 to the negative 4 molar. And so now on our calculator we'll do, make sure you use parentheses. Why don't you stop the video for a second and give it a try, and then I'll show you the answer. Okay, so we have, let's see here, 1 second EE. Oh, I'm going to back up here. I'm going to put this in parentheses. 1 times 10 to the negative 14, close parenthesis, divide by, parenthesis, 4.5 to the negative 4, close parenthesis, enter. 2.2 times 10 to the negative 11. 2.2 times 10 to the negative 11. That's the OH concentration, so you can see that's really low compared to the hydrogen or hydronium ion concentration. Remember from our previous lesson, this can be thought of as H3O+. And that's quite a bit higher, so this is acidic. Okay, and the next problem now. Let's see, where else might we go here? What is the pH of a solution that has H plus concentration? Okay, there's our H plus. Now we're going to go from here to here. So we're going to use this B equation. And so that's pH equals negative log H plus. And pH equals the negative log of that number. That's the H plus, 3.3 times 10 to the negative 3. And so here I'm going to type the negative button and then the log button. Where'd that go? There we go. Log, and that gives us a parenthesis to start with, 3.3, negative 3, close parenthesis. And that gives us 2.48. 2.48. Is that acidic, basic, or neutral? Well, we have a low pH, 2.48, so that's more acidic. And the H plus concentration, 3.3 times 10 to the negative 3, again in that area right there, so that is definitely acidic. Okay. And this next one here, what is the pH of a solution that has an OH concentration of 8.4 times 10 to the negative 13? Is this acidic, basic, or neutral? So we want to find the pH, but this time we're starting with the OH. So there's two ways to get there. We can go this way with this little fanciness up here, or we can do a two-step problem from here to here. Oops, sorry. We're trying to go from hydroxide to pH in this problem. So we can use those two equations right there, or we can do a two-step from here to here, and then from here to here. So that's what I want to do to start with, a two-step. So I want to go from the OH to the H plus first using that equation, and then I'm going to go to pH using the negative log equation. So two-step problem here. So let's see, we're going to divide the OH underneath here, and that OH is 8.4 times 10 to the negative 13. And when we do that, we get 1, parenthesis, 1 second, negative 14 closed, divide by, parenthesis, 8.4, negative 13 close parenthesis equals. Okay, so the H plus 0.0119. Notice it's not given this to us in scientific notation because that number is pretty big, as acids and bases go anyway. So now we're going to have to take the negative log of that button. And so we're going to do pH, so we're going to do negative log. There we go. And we're going to type in that number, 0.0119, close parenthesis. And that gives us 1.92. So 0.0119, that's what we just did there, the negative log of that number. That gives us 1.92 is our pH, and that's a very low pH. And we could tell right at the beginning because this hydroxide was very low in concentration, and the H plus we got from it was much larger than that. So lots of hydronium ions, so that's acidic. Okay. Just a couple more problems to do here. Okay. This next problem, number 5, it's to do that last problem the same way. So here it is retyped so we can see it. And what we're going to do here is we're going to do the pH plus POH equals 14. And so if we move this around to the other side, we get this equation. And remember POH, or actually I did not remember, I haven't told you this yet, but just like pH is negative log of H plus, POH is the negative log of OH minus. So that's what we're going to slip in to this little spot right there. So pH equals 14 minus, and now POH is the negative log of OH. And so all I have to do is plug in that concentration, 8.4 times 10 to the negative 13. So eventually, once you've done this problem a bit, it really boils down to this one equation. And so it's one step instead of two. And now we're going to do 14 minus, and I'm going to start over here, 14, hit the minus button, minus, and now in parentheses, negative log, and 8.4 second, close parenthesis, and that should do it. I got to close one more parenthesis to go with that one right there, and enter. And we get 1.92, same thing we had last time, and again, that's acidic. Okay. The next one, I'm going to clear here. What is the H plus concentration of a solution with a pH of 9.2? So that equation is going from here to here. It's going backward, so it's the opposite operation right there. H plus is 10 to the negative pH. The H plus equals 10 to the negative pH, so that's 10 to the negative 9.2. Okay, this problem right here, 10 to the negative 9.2. And so let's see. I'm going to show you on this calculator real quick because I know how to use this one a little better. Let's see. I should probably show you this one doing some of those other problems too. Negative 9.2. I put the negative in afterwards. Then I'm going to hit the 10 to the X button. So this is 10 to the negative pH, 10 to the negative 9.2. And that's 6.3 times 10 to the negative 10. Times 10 to the negative 10. And that's pretty low compared to what is neutral. So that's down around here. So this is basic. And let's take a quick look now again here. Let's see here. We should have a 10 to the power of X button on here, right there in blue. So that's the second of X squared, right? So the inverse operation, let's see here. That was a pH of 9.2. Okay, so I'm going to type in 9.2. No, I got to do negative on this calculator first. Negative 9.2. And then I'm going to hit second. And that button right there. Well, let's try this a little bit different way. Let's hit that button first. There we go. 10 to the, now we get to type that in. And that's a negative 9.2. And hit enter. And there we go, 6.3 times 10 to the negative 10. All right. And the next one, what is the pH of a solution that has 4.7 grams of hydrochloric acid dissolved in 1 liter solution? So here we're not told the molarity of the hydrochloric acid. We're told how many grams are dissolved in a certain amount of water. So we have to figure out the molarity first. So that takes us back to the first part of toxins. 4.7 grams times 1 mole per 36.45 grams. That's the molar mass of the HCl. So that gives us the number of moles, which that equals 0.13 moles. Moles, because here the gram gets canceled by the gram, and that leaves us with the moles. So 0.13 moles, and that's going to be dissolved in enough water to make 1 liter, which will give us 0.013 molarity, or moles per liter. When you get down to these problems, you're going to see that there's 2 and 3 liters, so be careful. That number can change. It's not always 1 liter. So that gives us the molarity, so we just need to take the negative log of that, the negative log of 0.13, right? That's the equation, so we just plug that in, molar. And so here we go. We're going to do negative log 0.13, close parenthesis, enter. There we go. pH is 0.88 is the pH. Okay, so that's a pretty low pH because that's a lot of H+. That's a pretty high concentration. So that's acidic. Okay, one more here. What is the pH of a solution that has 0.24 grams of NaOH dissolved in that many liters? That's my family calling, so I'm going to end it here. You got a good skeleton started right there. It's just like this problem up here, except this is sodium hydroxide. So you're going to find your molarity and make sure you're dividing by 2. And then you're going to use that equation to find the H plus from the OH that we're starting with. And once you get that H plus, you can, and there it is using that equation there, you can take the negative log and you'll find your answer. And there's one more for you to do again from scratch. So we're going to call it good there.